All righty. How's everybody doing today?
Good. All right.
Cool. Okay. Fantastic. So just again, a quick reminder, the class is being split up today. So this room is for people who normally sit and have lab in my room. If you normally have lab in Fred's room, then you want to go and meet over in Fred's lab, and he's going to do the lecture over there. That's just going to be for the next 5 classes or so, and then after that, we'll switch over. So, all right. So today we're going to start with a quick review of the oscilloscope and function generator. We'll talk a little bit about that, and then we'll go into our lecture. So the lecture today is all about soldering, and there are two important factors that lead to good solder joints, and those are cleanliness and heat. So those are the 2 things that you really want to focus on when you're soldering, and so we'll talk about those, and then we'll go on and do a preview of today's lab. So are there any questions before we get started? All right, cool. So let's start with our review of the oscilloscope and function generator. So let's talk about the function generator first. So what was the main purpose of the function generator?
Signal.
To what?
Signal, electric signal.
Yeah, so to generate electric signals, right. So it creates these signals, and it can create different shapes of signals. Anybody remember one of the shapes that it can create?
Square wave.
Yep, square wave, perfect. So that looks kind of like this. And what was another one? Triangle, perfect. And then what was the last one? Sine wave. Exactly. So the generator creates these different types of signals. And then you could also change some of the properties of these signals. What was one of the properties that you could change?
Amplitude.
Yep, the amplitude. So you could set the amplitude, and the amplitude was kind of how large or how small the signal was. So you could have a small amplitude signal that looked kind of like this, or a large amplitude signal that looked like that. And what was the other property that you could change about a signal? Frequency, exactly. You could have a low frequency signal that looked kind of like that. Or you could have a high frequency signal that looked more like that. So the main purpose of the function generator was to create electrical signals. You could choose what shape your signal was, and you could also set the amplitude and the frequency of that signal. And that's what the function generator does. So are there any questions about that? Okay. Then the other piece of equipment that we looked at last time was the oscilloscope. Now, what did the oscilloscope do?
Showed a visual representation of those waves.
Yeah, exactly. So yeah, it and displayed electrical signals. And it did this over some period of time. So it wasn't, we've already looked at voltmeters, and voltmeters will measure a voltage at a particular instant. But the oscilloscope measured this voltage over a certain period of time. So we could see how that signal changed over that period of time. And we said that oscilloscopes were kind of like cameras. So remember, just like a camera can take a picture of a landscape or some subject. And when it takes that picture, it doesn't actually change the subject. It just takes an image of it. And the same thing goes for the oscilloscope. When you hook up your oscilloscope to your circuit, your oscilloscope will measure that circuit, but it won't actually change the signal that's going on in that circuit. It will just show you what that signal looks like. And now also, we said that one of the most important features of a camera is often its zoom capability. You can zoom out and take a picture of a whole landscape, and then you can zoom in on one particular detail so that you could see that more clearly. And we said that the oscilloscope can do the same thing. You can zoom out and see a big picture of your signal, and then you can zoom in to focus on one area that might be more interesting. So on the screen of the oscilloscope, there were these little dashed lines, and they broke the screen up into these little rectangular boxes. And these boxes are called divisions, and they help you measure the signal that's on the oscilloscope screen. And we said that at the bottom of the oscilloscope screen, there were indications to tell you how big each box was. So there was something that showed the volts per division, and then also another place where it showed the seconds per division. So let's say that there were 3 volts per division, and we had a signal that was something like this. What would be the peak-to-peak voltage for this signal? One box is 3 volts tall. So because there's 3 volts per division. Yeah, so it would be 6 volts peak to peak, because there's 2 divisions from the very top of the signal to the bottom, and each division is 3 volts tall, so that would be 6 volts from the top of the signal to the bottom. So that would be 6 volts peak to peak. And then we also said that you could measure the period of a signal. And the period of the signal was the time that it takes for one complete wave to occur. So here the period would be, we could measure it from when the wave crosses the middle line going up to the next time it crosses that middle line going up. So for instance, that could be from here to there. And say that there were, say that there was 0.5 seconds per division. What would be the time for our period of the signal here?
From what point?
Well, so let's measure it from the time when it crosses this middle line to the next time it crosses that middle line going up.
2 seconds?
That's right. It would be 2 seconds because there's 4 boxes, 4 divisions, and each division is half a second wide. So that would be 2 seconds altogether.
How did 2 seconds or 5 seconds? Oh, that.
Sorry, yeah, it's 0.5 seconds per division. Yeah.
So lost.
No, yeah, I'm sorry. So the period is 2 seconds. And we said that if you know the period, we could use a formula to calculate the frequency. So anybody remember what that formula was? Yeah.
1 over period.
Yeah. So the frequency is 1 divided by the period. So in this case, the frequency would be 1 over 2 seconds. And so the frequency is 0.5 cycles per second, which is also called hertz. So that's the frequency. It's 0.5 hertz. And if we know the frequency, we could calculate the period also. We have another formula for that. We would just say period is 1 over the frequency. Okay. So that was kind of what we talked about last time. So the oscilloscope measures the electrical signals. You can zoom in and zoom out, and you can use these divisions to help you get approximate measurements. Now, the oscilloscope also had more precise measurements, so you might ask, well, why even bother looking at these divisions when the oscilloscope has these measurement capabilities built in? We could just use the oscilloscope measurements. Well, it turns out that sometimes those oscilloscope measurements, the automatic ones, they can make mistakes, especially if you have a wave that's not perfectly flat. Maybe you have a wave that looks kind of like this, and you want to measure the overall frequency of the whole wave. Sometimes the oscilloscope will do that for you, but other times the oscilloscope will look at this and will kind of will pick up the frequency, this faster frequency instead. So it's a good idea to be able to kind of eyeball this and get a good approximation of what you think your signal is, and then, or what you think your frequency or your period should be, and then you can compare that with the oscilloscope measurements. And if the oscilloscope measurements are pretty close, you could say that they're probably accurate. If the oscilloscope measurements are 10 times bigger or smaller than you think they should be, then something might be off. You might have to make some adjustments. So that's what's going on with the oscilloscope. It measures and displays electrical signals. Any questions about that? Yeah.
I just want to make sure that the frequency is measured in hertz. Period, I just want to make sure, is it still measured in seconds?
Yes.
Okay.
Yeah, exactly. So, yeah. Other questions? Okay. All right, so then let's go on to our main topic for today, which is soldering. So this is pretty cool. This is always fun because once you learn how to solder, you can actually make your own circuits and circuit boards. You can start repairing, electrical components that you have around. You can repair some instruments or solder up your own instruments. So this is a really cool skill to have, and it's really not that hard. So plus it's fun to go in and actually make stuff. So I think that this is going to be a good time. So we're going to spend the next 5 lectures working on soldering. we're going to do some basic soldering practice today, where you get to just kind of learn some of the basic skills. And then the next 4 classes will be spent on actually building your own fiber optic communicator. So this is a board, a kit that will actually allow you to speak into one board and have your voice come out the other board on the other side. So so that's the idea. So today is like a warm-up. Today is a chance for you to practice and get ready so that when it comes time to actually building the communicator board, you have a little bit of experience, and you can make that board look really nice. So, all right. So basically, for soldering, there are 2 key things that you want to keep track of. There are 2 things that you want to strive for. You want to be clean when you're doing your work, and you want to have enough heat when you're doing your work. So if you can achieve those 2 things, then you should have a good solder joint. So let me talk a little bit about those. So first of all, cleanliness. Basically, the reason that we have to be clean is because we're trying to join 2 pieces of metal together, and any kind of dirt or oil that is in that joint can cause the metal to not make a good connection. So we want everything to be clean. So there's a couple of things that you can do to maintain that cleanliness. First of all, make sure that your hands are clean before you start working. So wash your hands. And then, because you're going to be touching your parts, you're going to be touching the solder. So if you have dirt or oils on your hands, it'll get all over. Second of all, make sure that your surfaces are clean. And I will show you how to do that in a minute. But basically, we have a couple of ways of doing that. We have some little brushes that you can use to. There we go. So the first thing that you might want to do before you start soldering is use a little brush and clean off your surface. So there's a little brush like this. We have a little jar of alcohol, and you can get a little bit of alcohol on the brush and clean off your that's okay. You can clean off your circuit board. So that's the first thing. The next thing is we have these little wipes. They're like little tissues, but they don't cause as much dirt or dust or lint, I mean. So you can use a little tissue to wipe off your board as well. So those are the first ways that you can clean off your board. And I would recommend that you do this cleaning often. So I would use the brush and the alcohol before you start. And then you can use it as well while you're soldering. So after you solder in a few parts, you can go in and clean things up again. And then also when you're all done, you can do a final cleaning where you go in and make sure you've gotten all of the stuff off of the board, because soldering creates its own residues, and we'll talk about that in a minute. So yeah, so use the brush and the alcohol and the tissues early and often, and that'll keep everything clean and make some good joints. One of the reasons that we have to clean while we're soldering is because of the solder itself. So the solder that we use, solder is this very thin metal that melts at a low temperature. And we use this, we melt it and we put it on our joints in order to make a good connection. And this solder actually has a cleaning agent built in. So this is called, the cleaning agent is called rosin, and this is called rosin core solder because in the middle of the solder there's actually a little bit of rosin. So rosin is this cleaning agent that will do kind of a final cleaning while the joint is being made. But this rosin actually comes from, it's like the rosin that would be on a pitcher's mound in baseball. It's derived from pine sap. And so when it melts, it leaves behind kind of a thick, brown, sticky residue. So you want to get that off of your board. So that's one of the reasons that it's important to clean up as you go along, to get rid of this rosin as you're working. The rosin will actually burn up while the solder, or at the temperature at which the solder melts. So you'll see in a minute, I'm going to do a demonstration. You'll see that when you melt the solder, it'll actually smoke a little bit, and that's the rosin burning up. And after maybe 20 or 30 seconds, it'll stop smoking, and that means that the rosin has all burned up and is gone. So you actually want that rosin to be in your solder while you are making your joints. So what that means is that you want to put a little drip of solder on your iron and then use it while it's still smoking. If you get to the point where all the smoking is stopped, it means that all the rosin is gone and it's not going to do that work to clean your joint anymore. So if you get to the point where your solder stops smoking, you want to just wipe that off and get a new drip on your iron. Okay. So that's what I wanted to say about cleanliness. So just make sure your hands are clean, make sure that your surface is clean with the brush and the tissue and the alcohol, and then make sure that you have rosin in your solder while you are soldering. So that's how we can be clean when we're doing the soldering. So the next thing that I wanted to talk about was heat. So when we're soldering, we're joining two things together. So we could be joining two pieces of wire, or we could be joining a wire and a board, but we're going to be joining two different things together. And we're doing that by basically melting the metal. So what we want to do is we want to have some solder kind of flow in here and make a nice connection between our components and fill up this space and make a nice solid connection. What happens is that in order to do that, we have to actually melt the metal. So if we don't heat things up long enough, what can happen is that you can have a bead of solder that melts and then just kind of sits on top of the metal. And this is bad, because you just have a little tiny connection point between the solder and the pieces that you're trying to join together. And that's bad for a couple of reasons. First of all, that little tiny connection point doesn't make a good electrical connection. So there can be a lot of resistance. Also, that little tiny point doesn't make a strong mechanical connection. So it can easily snap off and fall away. So what you want is something like this, where the solder flows over and really flows all around and makes a good strong connection to your components. And what's more, really what you want is you want the outside metal on your components to actually melt and sort of mix in with the melted solder a little bit. That way, that's called an intermolecular bond, where these two different types of metals actually mix a little bit. That's what you're looking for. That's a really good, strong solder joint. Whereas over here, you just have kind of one thing sitting on top of something else, and it's likely to break. Okay, so really, this is our goal. This nice, strong bond. And in order for this to happen, you need the metal to be really hot so that the outside of that metal, the components, start to melt and mix with the solder. So that's why we need so much heat. We need the outside of these components to start to melt. This type of joint is called a cold joint because it happens when you don't have enough heat to melt the outside of these components. So we need to ensure that we get enough heat. And the way that we do that is that basically you bring the soldering iron in from one side of your part, and then you bring the solder in from the opposite side, and you leave the solder there until the component is hot enough to actually melt the solder. So that way, if the component is hot enough to melt the solder, then the component is hot enough to actually make a good connection to it. So that's a way that we ensure that the part is hot enough. You bring the soldering iron from one side, you bring the solder in from the opposite side. So that's the basic idea. That's how we ensure that we have enough heat. And then when we have cleanliness and heat, that's when we get a good solder joint. So any questions about that? I'm going to do a demo here. So why don't I fire that up, and then I think that'll make things clearer also.
What was that? What was it? Was it molecular bond? What was it called?
Yeah, an intermolecular bond. Yeah.
If you have like that little ball, the cold joint, and it like falls off and starts rattling it out, would that also be a risk of like shorting other stuff on the board?
Yeah, absolutely. Yeah, that'd be bad too. So yeah, there's nothing good about it. Yeah.
What were those little tissues called?
They're called Kim wipes. Kim wipes. All right, so this will be our lab preview here. So there's a couple of things that we need when we're setting up for our lab. First of all, everybody needs a pair of safety glasses. So you may have brought your own, and if you did, that's great. We'll be wearing these in the lab all day today and anytime we're doing soldering. If you haven't brought any, that's fine too. We have some that you can use. So we'll give some out. I recommend that you write your name on them because everybody is going to have the same kind, or a lot of people will probably have the same kind. And we'd like you to hold on to these and bring them back and use them next time. So make sure you write your name on them so you know whose is whose. When you go into the lab, everybody you'll grab a board like this. This is going to go underneath all of your work on top of the table, and it'll catch any drips of solder that might fall down. So that'll be the first thing that goes underneath. In each group of 2 or 3 people, each group should grab a kit of soldering tools. The kit will look like this, so you need to grab one of those, and that will have most of the parts that you need. When you get to your desk, you'll have a soldering station that looks like this. So the soldering station, when you get to your desk, you'll want to turn that on. So there's a little switch at the bottom, you turn that on, and then there's this knob, and you're going to turn that up to halfway between the 6 and the 7. So that'll be 650 degrees. So that'll set your temperature of your iron to 650 degrees. And when it turns on, at first, you'll see this green light is on solidly. That means that the iron is heating up. When the green light starts flashing, that means that the iron has come up to the correct temperature and it's ready to use. Each soldering station is going to have a little sponge, looks something like this. You need to wet the sponge before you start. So there will be a bottle of water that looks like this. So all you're going to do is you're going to squeeze the bottle of water and spray some water onto the sponge. You want to get it wet all over until it's pretty much soaking. And then when it's wet all the way around, you can take it over to the trash can and just squeeze out a little bit so that it's just, it's damp, okay? It doesn't have to be like dripping, you just want it to be damp, okay? So then you can put that back in the holder in front of your soldering iron. All right, and now you can see that the light on the soldering station is blinking. That means that it's ready to go. All right. So in the lab, we want to do 3 things today. The first thing is we want to solder a wire to another wire, or solder 2 ends of a wire together. So that'll be the first thing. The second thing is that we want to solder several resistors into a circuit board. And then the last thing is we want to remove and desolder at least one of the resistors from the circuit board. So those are the 3 goals for the lab today. That'll give you a chance to practice 3 different soldering operations. So let's look at the first thing. So the first goal is to solder 2 ends of a wire together. So we're going to use this tool to help us out. This is called a helping hand because it's got 2 little alligator clips that can hold some pieces for us, kind of hold things together where we want them while we do the soldering. So we'll use that to hold stuff for us, and then everybody is going to go and grab a piece of wire. So we'll have a spool of wire, and you'll cut a short length of it, maybe 6 inches, like this. You'll use these wire cutters to cut off a little bit of the wire. The wire cutter should be in your kit. And when you get the wire, it will have insulation around the outside. This insulation is this plasticky coating around the wire, and that keeps you from getting shocked if there's a voltage on the wire. So before you solder, you need to take this insulation off. And the way that we do that is with these wire strippers. So what you're going to do is there are different numbers next to these holes that correspond to the size of the holes. So the smaller the number, the bigger the hole is. So this is 22 gauge wire. So what you'll do is you'll find a pair of wire strippers and you'll look for the hole that has a 22 next to it. So on this pair, that hole is right there. So what you'll do is you'll put the wire right in that hole. You'll clamp down on it, and then you should just pull it off, and then it should be stripped. Really, that's how long it should take. The other thing was just ridiculous. Thank you, thank you. Yes, I'll be here all week. All right, so you're going to do that at both ends. This type of wire is called stranded wire because if you look closely, you can see that it's got multiple strands in the middle. This makes it more flexible. When you're soldering this type of wire, what you want to do is you want to make sure that all of those strands stay together so that they don't end up sticking off and poking out. So the way that you can do that is just grab a hold of them and give them a little bit of a twist. So twisting them keeps them all together in one bundle. So you want to do that at both ends. And then, like I was saying, you want to have a good, strong mechanical connection between these two sides, so that they don't rely just on the strength of the solder joint. So the way that we can do that is that we can put a little loop in each end. So put a loop there, put a loop there. And now the wire itself is kind of providing a mechanical connection. So we don't need to rely so strongly on the solder joints. Also, this will help keep the two ends of the wire connected to each other while we're doing the soldering. So it'll make that process easier as well. So once we have the wire stripped and connected to itself like this, we can actually start the soldering process. So the first thing you're going to do is you're going to clean the tip of the soldering iron. So the soldering iron might have some residue on it, and it might be a little bit dull. So we want to clean that off. And then it should be much shinier. And then what we're going to do is we're going to take a little bit of solder and put a little drip of solder on the end of the iron. And you can see it starts to smoke. That's the flux that I was talking about. And this little drip of solder on the end of the iron helps to conduct the heat from the iron to the joint. Now once we have this drip, we're going to put the iron on one side of the joint. In this case, I'm coming up from below, and I'm going to count to maybe 5, and then I'm going to come down from the top, and I'm going to start painting the solder all over the joint where I want it to be. So you just paint the solder in there until it kind of covers everything, and then you move the solder away and move the iron away, and that's your solder joint. So so that's pretty much what you want. When you're done, you want to inspect the joint and look for a couple of things. First of all, you want to make sure that the wire is covered all over with solder. So you don't want any patches of bare wire sticking out. Also, you want to make sure that the